Every day we waste without knowing the secret. Take a look at this peeled orange peel. After the fragrant yellow orange peel is peeled off, there's always something left behind. The white, pale part is sometimes annoying because it's difficult to remove from the pulp. It tastes bitter, and its texture is like cork. But have you ever stopped and asked yourself, why is it white? Why is it spongy? And what exactly is it for inside the orange? Today, I'm going to take you deeper than just eating the flesh. Ready? Let's get started. Part 1. The mystery of white color and sponge texture. Why is this part pale white, not green or yellow like the outer skin? This white part has a cool name, namely albedo. This name comes from the Latin albus, which means white. In the outer skin of the orange, which is yellow, there are pigments called carotenoids and chlorophyll. But once we enter the albedo layer, the pigment factory closes. The cell walls are transparent, and the cavities between them are filled with air. Then why does it feel like a sponge or solid cork? Now imagine an orange without albedo. Once it falls from a tree 3 meters high, the water droplets inside will burst and the orange will immediately be crushed. This albedo is a natural airbag and shock absorber. Part 2. Why are there yellow stains? Is that orange juice? Sometimes in the white part, right at the border with the outer skin, there's a tinge of yellow. Is this because the orange juice is seeping in? The answer is no. The orange juice is tightly contained in a juice sac covered by a waterproof membrane. This ripening process not only occurs on the outermost surface of the skin, but also seeps slightly into the outermost cells of the albedo layer. This is evidence that this orange is ripening naturally. Part 3. A secret soft touch. Now hold the albedo. Press it with the tip of your fingernail. It feels springy and soft, like foam rubber. Why is it so springy? It turns out it's due to a magical substance called pectin. Pectin is a soluble fiber, and its job is to hold cells together. The pectin content in citrus albedo is incredibly high, making up 26% of its dry weight. When pressed, this gel matrix absorbs the pressure and slowly returns to its original shape. Part 4. High fiber facts that are often taken away. Research shows that removing this white part can remove about 30% of the total dietary fiber in an orange. Fiber doesn't just promote regular bowel movements. It's a favorite prebiotic for the good bacteria in our colon. They produce anti-inflammatory compounds that keep our gut healthy and prevent leaks. Part 5. Microscopic observations. Another world behind the eyes. Under a microscope, the albedo cells don't stand alone. They're connected by a kind of tunnel called plasmodesmata. Their function, gossip and logistics. Through these tiny pathways, the albedo cells whisper to each other. Hey, it's getting dry here. Send some water from over there. Or, oh no, there's a fungus infesting the right corner. Close all the doors. With plasmodesmata, the albedo is a living, caring network. Part 6. The color gray comes. The battle against oxygen. Why does the color turn blackish gray after prolonged observation? Inside the albedo cell, there's a compound called polyphenol. There's also an enzyme called polyphenol oxidase. As long as the outer skin is intact, the two are separated by a cell wall. Once we peel it off and expose it to the air, oxygen invades. The polyphenol oxidase enzyme immediately reacts with oxygen and converts the previously colorless polyphenol into a brownish or blackish-gray pigment called melanin. Part 7. Pipe-flowing jelly architecture. Under the microscope, it looks like clear jelly, but there are tiny pipes connected to each other. Why is it shaped like that? The structure that resembles tiny pipes inside the pectin jelly is called the transport vessel bundle. There are 2 types of pipes. Namely, the first is xylem for water and minerals, and the second is phloem for food delivery. Why does it have to be shaped like a pipe? Because of the laws of fluid physics. To move fluid from point A, tree, to point B, fruit, against gravity, a long, continuous tube-shaped channel is needed. And why is it surrounded by pectin jelly? So that these pipes do not bend or break when the fruit is shaken by the wind. That concludes our video this time about the secrets of the inner skin of sweet oranges. Don't forget to support this channel by liking, subscribing, and turning on the bell. See you in the next microscope adventure video, and thank you for watching this video to the end. I hope you found it helpful.